So this is a two-part review on the metric system and using metric prefixes to do metric conversions. Step number one is where to find some tables of some metric prefixes. So in Brown-Lemay-Burston, page 16, you can see the abbreviations, the prefixes, and the meanings right here in exponents, which is where you want to be. Then also in your notes, there's a really nice metric prefix table right here that I went and put in Notability, so then it's going to be real easy to see. Now, once you've found that chart, now you need to visualize which units are the big units and take up lots of space if there were distance, and which units are small. And I just happen to have a ruler right here because that's one that a lot of people can think through. So this one, the smallest increment in here is a millimeter, and so between 1 and 2 right here, there's 10 millimeters right in here. And then, of course, there'd be 10 millimeters in a centimeter. So that means there'd be 10 of these smaller unit right here, these millis right here, in these larger centis. And so you can always say that these are the smaller units down here, and there's going to be lots of these small units in these large units right here. You can also think of it in terms of centimeters. You know, in 10 centimeters right here, that's called a decimeter. So this distance right here would be 1 decimeter. You can see the prefix deci right here. Obviously, if you had 100 centimeters, you would have a meter, and so there would be 10 to the 2 right here of these in one of these meters right here. So always think that these are the small units down here. Whoops, let me get something so I can write with. These are the smalls right here, and then these are the bigs up here, and then keep that in your mind that you're always going to work from small to big, because then you can tell where you are and how many there are of each one. All right, never be afraid to use exponents and then make them relationships as fractions or as ratios, because then you can never go wrong. I know that there's all the ways you can count the number of decimals and the places that you move them, but this is a foolproof way, because you always have the exponent pieces right here on the chart, and if you just remember those, you can never go wrong. So, for example, we just talked about how there'd be 100 centimeters in 1 meter. You just learned about scientific notation. You can write that as 10 to the 2. So there's 10 to the 2 of these small units in one of these large units called a meter or a gram or a liter or a mole or a joule, whatever the base unit is right there. And so, since you know this relationship right here, you can write it as a fraction or as a ratio and then use it in a mathematical equation to do a conversion. So you can write it as 10 to the 2 centimeters or 100 centimeters are in 1 meter. Or you could say that in 1 meter there are 10 to the 2 centimeters. Either fraction is okay because each one of these is equal to 1 because they're equal to one another. Because if you take something and divide it by itself, of course it's equal to 1. These relationships right here, these fractions or these ratios, are the key to being able to do especially difficult conversion factor problems or ones that might not even have metric systems in them. All right, next, relate everything to the base unit. So the base units in the metric system are things like meter, gram, liter, mole, joule, watt, candela. You know, there's lots of different base units depending on what you're measuring. But always relate it. 10 to the 6th of these are in one of these because there's lots of these in one of these. Or you'd say there'd be 10 to the 4th meters, or 10 to the 6th meters, I'm sorry, in 1 megameter right here because you go up to the 10 to the 6th, and this one's obviously smaller than this one. All right, you learned about exponents. When you're multiplying numbers, you add the exponents. When you divide, you subtract the exponents. And we'll see that how some of that works when we do a few of the math problems here in just a second. Remember, you always count on this chart from small to big. So when you're relating two sets of units, always count from the small one to the big one. Don't go the other way. So count from here up to here all the time. So let's do some examples. Here's how many millis are in a kilo. So here's milli, that's my small unit. Here's my kilo right here. And if I just look at the exponent right here, it's 10 to the 3rd to get to a base unit. See the number right there, 10 to the 3rd to get to a base unit. That would be from milli to base. And then going from base to kilo would be another 10 to the 3rd. 10 to the third. And then when you multiply those two together, add the exponents. So there'd be 10 to the sixth of the small unit in 1 of the big unit. So my question to you is, which one of these is the small unit? Well, the milli, hopefully you said, because it says small right down here. So that means there would be 10 to the sixth milli, whatever it is, let's say it's millimeters, in 1 kilometer, if it were meters. All right, let's do that again. How many decis in a mega? And it could be a deciliter, a decigram, a decijoule, it wouldn't matter, but the prefix deci in a mega. So find deci, and then find mega. Figure out which one's the smaller unit. Well, deci is the smaller unit by far than mega, because it's down here where it says the word small. And so then you can see it's 10 to the first to get to a base unit. So deci is 10 to the first to get to the base unit. And then from the base unit to mega is 10 to the sixth. So you can see that 10 to the sixth right here. So 10 to the 1 times 10 to the sixth, add the exponents, 10 to the seventh of the small unit in the big unit. Well, which is the small unit? The deci. So there would be 10 to the seventh, or you could write it as 1 times 10 to the seventh. Deci, let's say it's decijoules in 1 megajoule. All right, let's try it again. How many nanos in a milli? All right, so where's nano? Ooh, nano is way down here at the bottom. Nano. 10 to the ninth to get me to a base unit. But wait, before I get to the base unit, I run right across milli right here. Oh, okay. So notice how it's 10 to the negative ninth for the nano. But then it's 10 to the negative third for the milli. I'll just use positive exponents because that's how many of the small unit there are in the big unit. So what's the difference between those two? Well, it'd be 10 to the sixth difference, right? There'd be 10 to the sixth of the smaller in the larger. Notice 9 and 3 right here because we're at 9 and we're at 3 right here. And so there'd be 10 to the sixth of the nanometers, maybe, in 1 millimeter. See how we related those two, and we just looked at the decimals to find those. All right, let's do one more. This weird shaped symbol right here is called micro. It's the Greek letter nu, and it's actually written like this, but when you write it on paper, it's kind of hard to write that way, so you write a little u like this. So how many micro, and let's say it's micrometers in a gigameter. First, figure out which one of these two is the smaller unit. Well, micro is way down here, and then find giga. Oh, giga is way up here. And it looks like we got 10 to the sixth going between here and the base unit, so 10 to the sixth for this. And then from the base unit to the giga is 10 to the ninth, so there's 10 to the ninth of the base unit in the giga. Multiply those two together, well, 10, then you get 10, and then you add the exponents, and 6 plus 9 is 15, so you have 10 to the 15th. All right, if you're good at doing those relationships, in the next video we'll use those relationships a lot to actually do some conversions.